So let's get started. So today we're continuing off where we left last week, adding and subtracting fractions, but without pictures. All right, the pictures weren't too difficult to deal with. All right, we took the same pictures, make sure they're cut up the same size, and you just counted the pieces. Pretty easy to do, but it got a little difficult when the numbers were like 48 boxes and you had to count these tiny little boxes. Lots of mistakes were made just counting the tiny boxes or trying to cut it up to those small pieces. So today we're going to do it without the symbols. How do you do it just with the math, right? Now, there are two situations that the fractions show up in. One is called like fractions. The other one is called, other situation is called, is it here? Unlike fractions. I didn't use the title, so we'll put that title here. Unlike fractions. I will come back to this. This is the back of the second page. Okay? All right. Now, the like fraction was the easy situation with the diagram. That is when the bottom numbers were the same. So when the denominators were exactly the same. Right? So I got a list of fractions listed there. I got 3/4, 4 over 2, 4 over 3, 2/4. Out of that list, which one of those or which pairs are considered likes fractions? Right? Which one's the denominator? Top or bottom? Bottom. Bottom. Right? Which ones are alike? The same. So which ones are those? Which ones have the same bottoms? Same denominators? Sorry? First and last. They both have a 4 in the denominator. Right? And this was the easy situation when we were adding and subtracting fractions. If you're adding like fractions, what was the rule? The bottom number stays the same. So over here we have 8 over 6 plus 7 over 6. The bottom stays the same. All right? And we just add the tops. Right? You go 8 plus 7. Right? What number do we get? What's 8 plus 7? Thank you. 15. Okay? So we're doing it without the diagram, without counting it. Now, when we started, we're on day 8 notes, Eli. Right?
There's a pencil.
Alright? Alright? So now, last time, I said there's one extra step we didn't really talk about. With adding and subtracting fractions, once you have your answer, we look at our final answer and we go, can we make this fraction smaller? The word for making it smaller is simplify, reduce. Is there a number that can divide both the top and the bottom?
Yeah.
What is it? Or is it Holly? I heard a yeah from that corner. No? Yeah. What number can divide top? There is a number that can divide the top and bottom.
3.
Well, 3, right? So at the final stage, here we go. Okay, we can divide this by 3. We can divide this by oops. That's a bad division symbol. We can divide this by 3. So we got 15 divided by 3 is 5, and 6 divided by 3 is 2. This is my final answer. Okay? Yeah? So with multiplying and dividing, we look at the tops and the bottoms, see if we can make it smaller. And that's what's the first thing we do. With adding and subtracting, we want to make sure the bottoms are the same. Add them all together, or subtract them. Once you got your final answer, then you look to make it smaller. All right? So that's what makes this chapter hard. You guys get really good at each individual thing, but there's like different rules for every single kind of calculation. That's where you start making mistakes. Like, oh, what was the rule for this one? What was the rule for that one? Do I simplify first? Do I simplify last? That's what you need to keep clear in your mind. Now, subtracting, right? Like fraction, just like adding the other day, right? It's the same rules. The bottoms stay the same. Maybe just subtract the tops. 8 minus 4. Right? It came down to 5 over 2. All right. So what's 8 minus 4? Right? What number do we get there? 4. Thank you, Aya. Now we look at our final answer. We have the 4 sitting there. So we have 4 over 6. Can we make this final fraction smaller?
Yeah.
Yeah, and we'll divide it by what number?
2.
So divide by 2. They're all both even numbers. So we divide by 2, right? And you get 4 divided by 2 is 2. 6 divided by 2 is 3. Right? And the same thing goes as the last one. I know there's some people in this room who are trouble simplifying. Most of the marks come from being able to add, subtract, or multiply, divide. Only partial of the marks come from simplifying. So if you have trouble simplifying, it's okay. You still get majority of the marks. Okay. So let's practice these. We don't need to do all of these. Let's go over to this side over here. I want you to practice, let's see. Let's go. Let's do C and D from question 1. And let's do A and B from question 2. So I'll pause this, I'll take a pause, let you work on those. Okay. So the first one, we should have had 13 over 9. Can we make this fraction smaller? No. So that's the thing. You can't always make it smaller. So it's fine to leave it like that. Next one, the bottom stays the same. What should we have on the top?
12.
12. And can we make this one smaller?
Yes.
Yes, by dividing what number, Arizona? 4. Now, some people walking around divided by 2, which is fine. Right? If you divide by 2, you would end up with 6 over 4. Then you would have to divide again to make it smaller, right? But if you divide by the biggest number possible, you just one less calculation you have to do. So if you divide it by 2, it's not wrong. It just means you need to divide again. It means you can divide by 2 again, right? All right. So now these two, right? The denominator is 10. What should be the top number? 4. What can we divide by?
2.
2. Divide by 2. Divide by 2. We get 2 over 5. All right. Bottom doesn't change. 7 minus 4. What number do we get? 3. Can we divide by anything?
3.
Yeah. Students often miss the divide by 3s. And all the what's the question? So 1 over 3. 3 divided by 3 is 1. 9 divided by 3 is 3. So that is the easy case. Is when the bottom numbers were the same, all you had to do is count. Right? So we have 12 eighths. We have 3 ninths. That was just the counting part. The hard part was on the back side. Okay, I'm gonna kind of skip around. I'm not gonna do all this in order. So let's go over here. All right. So the hard part was when the denominators were different. That's when we have unlike fractions. Right? That's when we drew the diagrams, rectangles, and we cut one vertically, cut the other one horizontally, then we kind of copied the things back and forth so we had the exact same number of pieces that they were cut into. So we're going to do that, but mathematically without the photo. Right? So how do we do that? Okay. So let's see if I can go back. Can I quickly go back? Let's go to here. Let's look at the assignment like this, right? Like, so what we did is we took the 2, we cut this in half this way, cut this one 5, and we went over top of each other, right? And we had made them 10 equal pieces. What we are doing here is finding a number that both 2 and 5 can fit in. This is the pure way of doing it. So that process is called finding a common denominator or a common multiple. Okay? That's what this is called, right? So if I go back to our notes here, and we want to find, oh, come on, my finger's not working. Uh-oh, what's going on here? Things are crashing. Okay. Instead of drawing this picture, we want to find out, hey, we need to make both of these bottoms the same. So we need to find what is the common denominator. What is the number that we can both make them the same? Because the word the common means same, right? So to do this, we think of what are the multiples of 4? What are the multiples of 6? What do they share in common? So if I grab my multiplication chart here, and this is, if you don't mentally see it already, you can use your multiplication chart. So if I have 4 here, oh, maybe I'll do it in yellow, highlight. 4 here, 6 here. We look across these columns, it's the multiples of 4, it's the multiples of 6. You look across and you go, hey, which ones are the same? Right? So we look across and go, hey, looking across, I got a 12 here and a 12 here. So the common number that we can change them into is 12. Peyton, do you notice?
Also, I think 24, is that another one of them?
Yeah, and you'll notice that there's actually multiple ones that work. There's 24, there's 36, there's 48. There's actually a lot of them that work, right? And so what we want to do is pick the smallest one. If you pick a bigger one, it's not wrong. They're still in common. It just means at the very end, last step, we're simplifying. You're gonna have to do more simplifying. That's all that means, right? So we look at this and we go, okay, we're gonna make both of the bottoms the same by changing them both to 12. So the 4 one, we're gonna have to multiply by 3. For the 6, we're gonna have to multiply by 2 to turn it to 12. Okay, so go back to our notes, I go, okay, I wanna change both of them to 12. Right, and I go, okay, to change 4 into 12 using my multiplication table, I need to times this by 3. Okay? Because 4 times 3 is 12. And I have to change the 6 to 12, I have to times that one by 2. Right? So, here's the thing. If we multiply the bottom, we also need to multiply the top. Right? So if we multiply the bottom by 3 here on this fraction, we also need to multiply the top by 3. If I multiply the bottom by 2 on this fraction, I need to multiply the top by 2. Right? Because when we were doing our notes, remember the number of pieces we counted also increased. That didn't change. So this is the most common mistake that students do. They do a good job, they find the common denominator, but then they forget to multiply the tops. They only multiply the bottoms. You have to increase the amounts that are in the top. So now I rewrite my new fraction. So I figure out what my new denominator is supposed to be, and I go, okay, it's going to be 12 here, so 4 times 3 is 12, and on the top, 3 times 3 is 9. And over here, I got 6 times 2 is 12, and 1 times 2 is 2. Okay? So just like last time, we did not change the value here. We just changed how the fraction looked so we could add or subtract. Like when we were doing the other day's notes, we're going back to our assignment, right? The amount that was shaded in didn't change. Just we cut everything up into smaller pieces. So we didn't change the value, just changed how it looked, so then we can do the adding, subtracting. That's all we're doing here. That's a very key thing to have in your mind. We're not changing the value, just changing how it looks so we can add or subtract. So now, since both bottoms are the same, we can add these, or subtract in this case. We go, the bottoms are both 12s, so it stays at 12. Right? We couldn't do that before. Hello, Kane. We're on day 8 right here, okay? So the bottoms say, all right? So now the tops, we go just like we did on the first side of the page. 9 minus 2. What number is that? What number? What's 9 minus 2? 7. Thank you, Eli. Okay. So see how much more steps are in this thing. This is why I saved adding and subtracting to the end. There's lots of steps to it. So now that we made the denominators the same, we did our adding and slash subtracting, we look at our final answer and go, hey, can this be made smaller? This is where we do our simplifying. Peyton says no, and I agree. So this is as small as this fraction can get, right? Okay. All right, so let's practice. Okay. Before I get you guys to do this fraction thing, let's look at, let's suppose that 6 and 9 are our denominators. Okay? Use your multiplication chart to tell me, oops, not there, over here. What would the common denominator be if we were using 6 and 9?
18.
Thank you, Guyana.
4.
Nope, 6.
24.
We have 6 and 9. Right here, right? 6 and 9. And we've got 18 that works. So we just look across, we go, okay. And you'll notice other ones probably work as well, right? We have 54 that works, right? But we want to pick the smallest one. So let's practice using this chart before going on. All right, let's try 8 and 12. 8 and 12, right? We have 8 here. We have 12 here. What is our common denominator? Look across, grab your sheet. What is the common multiple between 8 and 12?
24.
Thank you. 24. All right. So everybody should just have this in front of you, right? We're gonna look at this. All right, we'll do a bunch of these. We're gonna go off. We're gonna go away from our notes and just practice these.
48.
48 works as well, right? So you can use 48. You can use 24, right?
72.
72 as well. But we want the smallest one, all right? Okay, let's try another one. Let's go. How about, let's keep 8 the same. How about 8 and let's go for 18. Look across 8 and 18. What's the common denominator? What's the common multiple? 8 and 18.
72.
Thank you. So you have 72 here and 72.
144.
Yep.
260.
So there's going to be multiple ones, but we want the smallest one. Just makes a number smaller and other things work, right? So this is one of the reasons why when I made this multiplication chart, I did alternating colors so that makes it a little bit easier for you to track your finger and follow. Alright? Alright, so let's try a couple more. What if I go six and 15? Just give people a couple of seconds. Raise your hand, don't yell it out, right? Alright, alright, give people a couple of seconds. Grab your sheet. Look at it. Alright, give me a second here, Hunter, let everybody
60.
raise your hand. You should be doing this instead of writing. Practicing, man. So you don't go, I don't know, in a couple of minutes when I ask you to do this. Alright? Grab it on the other one. We've got lots of these. Grab it on your notes one. Aya, did you find it? What is it? 30. 30 here. 30 here. Eli, did you find another one?
60.
60 works as well. And there's more.
90.
90. We picked the smallest one. Makes the number smaller. All right. Let's go. 3 and 4. Raise your hands. All right.
12.
Shh, don't yell it out, please. All right. Erza. 12. All right. Give people a chance. I'm glad some of you guys see it faster. If you are comfortable with your multiplications, you won't need this chart. You'll get to know that faster, right? It's like, oh, what multiples of are the 3? What are the multiples of 4? And you'll just know that they share 12 in common, right? How about, yes, Eli?
36.
Yeah, there are more that work. 36 that works.
60.
Where is 36 and 36? And is 60 in common? 60 is here. And here we picked the smallest one. How about we look at 3 and 12? Raise your hand if you can find it.
Wait, can you do this?
3 and 12. What's the common one? Right? Raise your hand. I want to see how many people can figure this out.
12.
Come on.
Put my hand up.
Okay. Aiken?
24.
24 works. Is there a smaller one that works? Brooke. 12 works as well. All right? So you could do 24, but 12 works because it's smaller. So let's simplify. We're going to have to do it at the end. Okay. Okay, let's go for one final one. Then we'll go back to our notes. Let's do 12 and 21. Raise your hand once you've figured out what is the common denominator between 12 and 21. Look across. Don't yell it out, please. Give people a chance to find it. Right? What is the common one? I'm glad that most people can find it. Alright.
Oh.
Pick Curtis because he hasn't answered yet.
84.
84. Thank you. Alright. So, I give you a giant table for most of the stuff that we're doing in grade 8. A giant table. This giant table will find all the answers. Sometimes you may have to kind of figure out what your multiplication is by your hand. Actually, I said that was going to be the last one. But let's try a slightly different one. So this is how we add fractions if you have two fractions we're adding. So we need to make both the bottoms the same. What if I gave you 3 fractions to add? Right? And each one of those 3 numbers had a different denominator, right? Then we'd have to find out what is common between all 3 numbers. So let's suppose I gave you the numbers 8, 12, and 18. So now look across 3 columns. Which multiple is the same amongst all 3? Raise your hand once you see this. Now, 1 person so far. 2, 3, 4, 5, 6. Give people a little bit longer, all right? 7, 8. I'm gonna ask Mason this time. Mason, can you tell me what it is?
36.
We have 36 for the 8. Looking across 8, there's no 36 in 8. So 36 doesn't work. Here's a
72.
look across. I see a 72 here. Now, it'll work as long as every single one has 72. 12 has a 72. And 18 has a 72. Right? Now, my question to you, is that the lowest one?
Yes.
Yeah. Right? So, if you can find one, that's great. You can always do the question. But finding the lowest one makes it easier. Hallie, do you have a question? Can we do a couple more questions without this? Then we're almost on our notes, so maybe we'll do a pause. Okay, let's go to our notes. All right. Let's put this into practice. All right. So we're going to add and subtract these 3 fractions. All right. Our goal is our first step to make the denominators the same. We have 4 and we have 3. They're different. What is the common denominator between 4 and 3?
12.
Thank you. Next time, hand up. All right. So we want to make it 12. So you look across. 4 and 3 shares 12. So the fraction on the left side, what do we need to multiply by? 3. Not just the bottom, the top as well. Fraction on the right-hand side, what do we need to multiply by? 4. Not just the bottom, the top as well. So we show our multiplying, we rewrite our new fraction. So 3 times 1 on the left side is 3. 4 times 3 is 12. On the other fraction, 1 times 4 is 4. 3 times 4 is 12. We have these 2 fractions. We put them together. 7 over 12. We have 7 twelfths. We have 7 of these. We're counting twelfths. We have 7 of them. Okay? All right. Next one. 3 and 2. What is the common multiple? What is the common denominator? So you can say this in a couple of different ways. Right? All means the same thing. Raise your hand once you find it.
I don't think there is one, is there?
There is. There is always one.
Oh.
There is always one. Jason, did you find it? What is it?
6.
6. Okay. So we go. They're both different. Oops. Before we make them the same, we look across the table. 3 and 2, they share 6 in common. So you're going to multiply this one by 2, top and bottom. We're going to multiply this one by 3, top and bottom. Okay? So we rewrite our new fractions. Do that calculation. 2 times 2 is 4. The bottom is a 6. 3 times 1 is a 3. The bottom stays a 6. And we have a minus sign. So we put this together. 4 minus 3. What number do we get? 1 over 6. That's it. Okay. Last one. Okay. 8 and 12. I did this as a warm-up one. You got one person who's figured it out. You give people more chances to find it. What's our common denominator between 8 and 12? Got 2 people, 3 people. More. Give people a couple more chances. And go for Syra, 24. Right? So, times this one by 3. 8 times 3 is 24. So we're using our multiplication chart, right? That's all this is where the numbers are coming from. Top and bottom. And if I go times this one by 2, right? And I go rewrite our new fractions. 3 times 5 is 15. 8 times 3 is 24. The other one, we have 24. We have 14 with a plus sign in between. The bottom stays the same. Sorry? 29. And I forgot to ask you the last time. Can we make this fraction smaller? No, we can't. Right? You can use the number line also to help you. Like 29 is a prime number, so prime numbers can't be made smaller unless you divide by the same prime number, right? So 24 can't be divided by 29, so it just stays like that. Okay. Now, let's suppose that when you're using that table and you looked across and you didn't see 24, but you saw a bigger number, what other multiples are the same? What's another one that 8 and 12 can fit into?
64.
64. Okay. So let's go like this. Is there another one smaller than that?
36.
36. Let's just work with smaller numbers. Right? It'll make our math a little bit easier to do. Okay. So now let's just do this question again. And suppose that, hey, you didn't see the smallest one. So you go, okay, you saw 36. How would that look like? Oh, I have to times this one by 4 to get to 36. Wait, 36 doesn't work. 36 doesn't work. 8 can't go into 36. 48 would work. There we go. All right? So if I go 8 times what number that gives me 48?
8 times
6. So I have to times this by 6, top and bottom. And I have to go this one. I have to go times it by 4, top and bottom. And I get 30 over 48 plus 28 over 48. And I need to add those numbers together. Right? And we get the bottom stays the same. We're adding bigger numbers. We get 58 on the top.
I just realized the reason why I thought it was that because I was apparently on the 9 column, not the 8 column.
Okay, that's okay. We make those mistakes. Okay, now this answer looks significantly different than the other one we just did. Right? But when you're adding the two of the exact same numbers, the answer should be identical. The difference is we can simplify this answer. Right? So we have an even number on the top, an even number on the bottom. We can divide both of these numbers by 2. And if we do that, we get 29 over 24. The same answer. Okay? So I can give you, so it doesn't matter which one you pick. You will always end up with the right answer, but you just may have to do more simplifying. If you pick not the lowest, so the phrase is, we're looking for not just the common denominator, we're looking for the lowest common denominator. This makes the math easier later on. Now, what happens, one more thing off of this, is what if I give you a number like 26 and 30? It's not on your table, right? And you, maybe with your mind, you can figure out the common multiple, maybe you can't. How do you do a question like that? Right? So, teach you another trick, right? So a lot of students, go ahead.
So like, I don't know how to explain it, but I did it on like the first question.
Okay. I'll come talk to you. I'll get your idea. So if you are ever stuck on an adding and subtracting question, a strategy that works 100% of the time is you can always multiply by the opposite denominator. Right? So for example, on this question here, right, if I had 5 over 8 plus 7 over 12, before we can add, the goal is just to make the bottoms the same. We would like to do it with the smallest number possible, but essentially we just need the bottoms to be the same. So what if you just multiply by the opposite one, it will work 100% of the time. So if I take this, and I go, okay, for the 8, I'm going to multiply by the opposite one, 12, top and bottom. For the 12, I'm going to multiply by the opposite denominator, 8, top and bottom. If I create my new fractions, the denominators will be the same. 8 times 12, 96. Right? 5 times 12, 60. 8 times 12, 96. Oops, 96. 7 times 8. We did this one. You guys gotta look it up. What's 7 times 8? 56. Right? So you can notice that when we're going to do this, the bottoms are the same, so you can add it up, but there's going to be more simplifying you have to do. So this trick will always work. Right? So by multiplying by the opposite, you're guaranteed to get the common denominator. It just may not be the smallest. Right? So with all of these questions, you can do it just by multiplying the opposite. You just may have to do more simplifying. Okay? So that's where I'm going to stop.